I'm excited to show you guys how to build a computer vision model within an app using no code at all. Here's our workshop agenda. I'm going to walk us through what an AI model is and what exactly is a computer vision model and go through some different types of computer vision models. After that, we're going to talk about EyePop and how EyePop fits into the computer vision solutions. And then next, I'm going to show you guys a demo of an app that I built, which uses computer vision, and I put this app together using no code, utilizing EyePop and Bubble. After the demo, I'm going to show you guys how I built that computer vision model exactly. And then I'm going to show you how I built the Bubble app. And then in the end, if we have some time for questions and answers, that's where we're going to handle that. Great. So what is an AI model? An AI model is a program that has been trained on a set of data to recognize certain patterns or make certain decisions without further human intervention. There are many different types of AI models, but we're going to be focusing on computer vision models. Computer vision models are trained to see and understand images or videos. So some examples of this could be medical imaging if you are trying to detect things in X-rays, self-driving cars, tons of different use cases for computer vision models. Some different types of computer vision models are object detection models. And object detection models can find specific objects in an image, video, or live stream, and they'll tell you exactly where they are by drawing these little bounding boxes on them. So if you wanted to count how many cows or locate a specific cow or track movement, um, that is a great solution. Another computer vision model is classification models, and these tell you whether a specific object or feature is or is not in an image. So there's no bounding box here. It's just is this present or not? And you can also classify between different types of objects you're detecting. So in this example, we use a classification model to detect that there is a pituitary tumor here. And it can also tell us if there's a tumor or not and determine between different types of tumors. Key point detection models are important for identifying points on a body, and this is really useful for sports performance tracking, understanding your form in a programmatic way. Segmentation models are when these models label every pixel in an image to show exactly what is what. This gives you precise outlines instead of those boxes we saw in the object detection model. And some use cases for this are medical imaging, self-driving cars, tons of different things. So the hidden work behind using a computer vision model, traditionally you would need a whole ML team, and it would take you about a few weeks before you could get your model up and running. This would involve having to code or train your own model using PyTorch, pre-processing your data, normalizing your data, running inference and post-processing, all these steps. And that's sort of where EyePop comes in. EyePop is a self-service AI platform designed to make it easy for anyone at any technical level to be able to have a computer vision model tailored to their specific need. So there's no AI PhD required. You can just have your own computer vision model up and running in hours. So the EyePop workflow sort of looks like this. You'll come in with your business data, and that'll be images, videos, live stream, and you'll upload that either to our SDK or our web app. And from there, you'll be outputted a POP, and this POP is essentially your computer vision solution. So you can then have your computer vision model running, and you will be outputted this rich JSON data. And with this rich JSON data, you can do tons of things. You can use it to power your product and get your desired business outcomes. So our pipelines are very low latency, and they're combinations of models working together um, to provide our developers with a rich set of data. So you can configure these on the fly, and you can combine different models together to get your desired solution. Are there any questions from this point? Okay, great. So now I'm going to be going through some different models we currently have on EyePop, which you can use right now. So if you have any use case where one of these models would be of value to you, then you could create an account and start using this today. So we have a model to detect people. People with 2D points, people with 3D points on their face and body and hands, people plus common objects, people plus animals, people and devices, people plus sports equipment, people plus vehicles, text detection and OCR. So if you have documents or PDFs where you need to extract information, this would be very useful. Vehicles angled on traffic cameras, sports player tracking, detecting there's a person and following, combining that model with the OCR, and person with demographics. So if you're trying to understand, gauge how old someone is or how what their facial expression might be saying, some really cool stuff. And you can even combine your own model with any other model in our pipeline. So for example, here, we trained a model on detecting eyeglasses, and we combined that with the model to detect people with their 2D stick figures drawn on them. So this is really awesome for creating a model and then combining it with something else to get even more results and more data that you can do tons of things with. So now I'm going to show you guys what app I built using Bubble and EyePop. But before we go on to there, does anyone have any questions?
I think you answered my question already. I had
Mm,
put in the chat. So the iPop can also recognize, say for instance, the car, but the license plate on the car with the text. So you got using OCR and the object uh identification, basically, if I'm saying it right. But
Yeah,
okay.
yeah, you can detect the car, and then you can also read off the license plate through OCR. So
Oh, so
yeah,
cool. Excellent. Thank you.
yeah, of course. Yeah, let me share my next screen. So with Earth Day coming up next week, I wanted to build something which was sort of environmentally friendly. And a problem I had was not knowing if something was recyclable or not. And this is a big problem because if you throw away something in the recycle bin, which isn't recycling, it kind of cancels out everything else you put in the recycle bin. So I put together a little app which will allow me to take or upload a photo, send that photo to EyePop, and EyePop will identify the material and determine if that's recyclable or not. And immediately after, I will receive feedback that yes, that is recyclable, or no, that is not. So let's just test it here. And this model that I put together is a classification model, and it's going to classify if the material that we are setting to it is a material which is recyclable. So the material is glass, and this is a response from IPOP. This line here, this is some post-processing I'm doing. So determining what the material is, it'll send a message if it's recyclable or not. So if we were to try this with an image of trash. It'd say this material is trash and that is not recyclable. And again, I was able to put this together with no code, just using iPop for the computer vision and Bubble to put together this front end. So now I'm going to be going to iPop. If you don't have an account, just go ahead and hop onto our website and you can click Get Started. You can make a free account and follow along from there. So once you get onto iPop, you're going to land onto a page which looks like this. So these are all my models, which I've already trained. And then below are all of our collections of images. So to put together a model, you simply just need to click Create New Model. And here we can pick between the different types of options, different types of computer vision models. So if you want to create an object detection model for finding a specific object and drawing a box around it, we could click this one. But today we're building a classification model. So we're going to auto tag the images with the different types of labels. So just go ahead and click Start. And now we're just going to need to name our model, and we're going to name it Recycle Scanner. And we're going to need to put some labels in here. And these labels are what we want to find in the image itself. So we want to determine if in the image we're sending, if the material is going to be plastic or glass or paper or cardboard, because these are all things which are recyclable. And what is not recyclable is trash. So this is sort of like our catch-all. If it's not one of these, then it's going to be trash, and therefore it won't be recyclable. All right, and now we just need to upload at least 200 images to train our computer vision model. So I've organized my folders in my images in folders, which look like this. So each folder is named cardboard box, glass bottles, and they contain the respective images. And this helps in tagging our images correctly. So once we upload them, it'll classify the images according to the folder. So it's folder tagging. And this kind of increases our accuracy. If we weren't to do the folder method, we have a auto labeler where AI will kind of sort out these things for us. But this just makes sure that we get some great results and kind of speeds up the process. So recycling is one use case we can use for classification. I thought it was fitting for Environment Earth Day coming up. But some other use cases we could use are, let me show you some examples here. So if we wanted to build a patient monitor, right, we would want to determine when a patient has fallen versus when the patient is not fallen. So if the patient has fallen, we want to classify that either that image, that video, that live stream, and we want to have that computer vision model detect when that patient has fallen. So right now we're uploading some images. So while this is uploading, I'm going to take us into what that next screen would look like. So here we can see that, there is a person standing, right? And there's no classification if they are fallen or not. And we can see the same thing here. This patient is in bed. This person is standing. But as soon as we get to a scenario where it is like this, we can see that we are getting the classification that this patient has fallen. When the patient is in their bed, there's no tag. So you can sort of imagine all the things that we can do with this. And for example, we have this confidence threshold, and we can increase it and decrease it. And this will pretty much show us what level of confidence the computer vision model has in that this tag belongs where it does. So if we were to, let me find an image where, it might not be too confident. So for example, here, we're at 64 confidence, and it is fairly confident that this patient has not fallen. However, if we were to decrease this, now we can see that it is guessing that this patient has actually fallen, but that's not correct. So if we were to increase our threshold, we can see that the model is certain that this patient has not fallen. So that's one really cool thing that you can do with classification models. Another awesome medical related example is medical imaging. So understanding the different types of tumors, if they are present based off their location, and you can actually identify and classify these tumors. So if we were to look in here, it will know that this is a meningioma tumor. This is a pituitary tumor just based off the location and the computer vision model training and being able to classify these. If there's no tumor present, then it will say there's no tumor. So this is just an idea of what you can really do with these classification models, especially using no code, just tagging them. Great. So now we go back here, and this is what our image set looks like from our recycle scanner. So we can sort of see that everything is tagged appropriately. So do we want to just go through here and review, make sure that trash is labeled as trash? We can actually just skip ahead. So we want to go through our data set and make sure everything is correct. We're going to be training a computer vision model on this, so it's utmost importance that everything is labeled absolutely correctly. So it was able to determine that this is all plastic. And yeah, it's looking pretty good. We can skip forward. So there's some scenarios where I'm kind of unsure, like, is this paper, is this cardboard? And if you run into this scenario, we don't want the computer vision model messing up, so it's better to just ignore them. Right? And if something's incorrect, like, this is obviously paper, but if it wasn't correct, we would change it and then we'd accept that. And now we do this whole process to go through all of our images, and we can kind of change the view and tag them like this as well. But once we go through all our images, we would get to the last one and we would accept it. And we'd end up on a screen like this. And this is a summary of all the images we've uploaded, how many we approved and how many were left unapproved. And it's going to show us the amount of negative examples here. So it's saying we have 0 negative examples. I'm using trash, the trash label, as a negative example. Basically, a negative example is a image where the label you are trying to detect is not present. So in the scenario for a recycle scanner, I'm trying to detect plastic, paper, cardboard, glass. And if it's not that, then I'm labeling as trash. But that trash label is also a negative example. If we were looking for livestock and looking at a field of grass with cows, then a negative example in that scenario would be a field of grass without any cows. And this helps the model learn and understand what not to look for, so it can handle all sorts of scenarios when it's actually live. So now we can see that there is going to take 29 minutes to train the count of all of our images, and we can just go ahead and click Start Training. So we're going to be asking questions, and this is going to help our computer vision model understand what it's searching. So does your object make sense in black and white? Yes. Does your object make sense upside down? Yes. Does your object make sense laying on its side? Yes. Does your object make sense with blur or noise? A little. Is your object something that can be behind other things? Yes. Are your images from a moving camera? No. Does your object exist outdoors where the weather may change? Yes. Is your object typically found far away? Mostly outdoors, yes. A little. Sweet. So now the model is beginning to train. And once we return to our dashboard, we'll see this little icon and we can see that it is beginning to train. Do we have any questions at this point?
Yeah, I had a question. How important is it to like build your own data set? Like you using images that you gathered yourself rather than, let's say, like a Kaggle public data set or from one from like RoboFlow where the images are already labeled and everything.
Yeah, it's a great question. So as long as those images are correlated to your actual use case and in the real life scenario, the model is going to be encountering what like variations, not exactly what it was trained on, but you're handling those things around it. It should be fine if you get your images from Kaggle or RoboFlow or Google, like that's definitely fine. But as long as you're labeling it and tagging it correctly is probably the most crucial thing.
Okay, thanks.
Yeah, of course.
Hey, that's totally right. I just want to jump in there too to say the other thing you have to look for is just the license around data sets that are available publicly. Some of them are marked for research only or other stipulations on those data sets, and you want to be careful around that. If you're searching like on Google, like looking for a Creative Commons license is usually good for most use cases for how you train a model. And so just be aware of the licenses on data you're using.
You dragged a series of folders up. I was curious, is it possible to drag a zip file that contains all those folders up and have it extracted?
Andy, do you want, I'm pretty sure we're working on this feature.
Yeah, right now it just accepts unzipped folders. That's something that it's we're working on. It's on our roadmap to not only accept zips, but also videos as input data. It's really easy to get a lot of frames of your object or condition that you're looking for in video. So that's a great source of data for training models. So right now you would have to explode those videos yourself into frames. Shortly, we'll be able to accept those as input data as well.
What's the is there a max amount of images? I know more is going to be better, of course. Is there a maximum amount of images that you'll accept?
Yeah, right now on the basic plan, the hard limit is at 5,000 images. It's a soft limit. You can actually upload much more than that, but you'll find it gets limited in the auto labeling piece there. So technically there's no limit. We've trained models in the 2 million range, 2 million image range. So we don't have limitations, but there may be limitations based on the plan you're on.
once the models are uploaded, then and the model is trained, the images themselves, do they just get tossed?
They actually stay in your account. So we don't, as EyePop, we don't use them for any training on our side. It's just for your usage. But it's important to keep those in there because you may come back to this model later and say, hey, I want to add even more data now to this model. And so I want to retrain on the entire corpus of data, where you may have some segments of that data that you want to pull for additional models around your use case. So it's good to have it all in there, but they are only accessible to your account.
Okay, great. So if I understand then, and this will be my last question for now, you can edit your trained models then.
Absolutely. Yeah, you should definitely think about models as an iterative process. Get them out there in the wilds in a proof of concept as soon as you can, because you're going to reach edge cases that you hadn't thought about in the initial data set. And if you look on the screen right here, there's version numbers next to a lot of those models there. And so yeah, so for example, some of Sharoz's models, he's trained a number of times. He's put in different iterations of work there as you find edge cases.
So in your estimate, is it better to refine an existing model or just start with a new version if you find that your model is not doing exactly what you had expected?
Usually you want to refine an existing one unless it's giving you just such poor data out that you want to start over. But generally that gets cleaned up the more data you add. And the more data you add, the better the auto labeling gets. So it gets easier as a human to actually put the labels on your models.
Phenomenal. Thank you.
Great, those are some awesome questions. So just to recap, we began training our model, and now we want to connect our model and start to actually use it outside of EyePop. So in order to do that, we'd go to our dashboard here. And you'll end up on a page like this. And each of these pages are going to be different models. So this is one model, this is the next. And we want to copy this UUID. This will help us figure out which exact model we're trying to access. And this will be useful for our bubble plugin. If we want to communicate with our model through the SDK, we can follow the instructions here between different languages. But for today's purpose, we're going to be doing the bubble integration. So our first step is to go to Bubble. And once we get to Bubble, we're going to end up on a page like this. To create the demo that I did with the Recyclable scanner, I clicked Create an App with AI, and you'll be led to a page which looks like this. And I put in a really simple prompt just explaining what I'm trying to build and the functionalities of it. So I typed in a clean modern app that helps users instantly determine if an item is recyclable. Simply snap or upload a photo of an object, and the app identifies what material it's made of, plastic, paper, glass, or cardboard, and tells you whether it can go in the recycling bin. Once you hit Generate Blueprint, you'll land on a page which looks like this, and this is a Bubble trying to understand what you're trying to build. It'll list out some different user stories and some key features. And then if you want to refine it even further, you can refine it right here. And then once you hit generate, it's going to take a few minutes, and then you'll land on a page which looks like this. And this is exactly what I did to get this design and this app in less than like 10 minutes. Now to tie in our EyePop model, which we just trained. So the first step would be to go onto this panel and click plugins. I already have mine added, but if you click add plugins and you type in EyePop, it'll appear right here. You just click install. And then once you install it, you'll land on a page which looks like this. And that pop UUID on the dashboard of EyePop, we're going to go ahead and paste that into here, as well as an API key. Once we've done that, then our EyePop plugin is officially hooked up. So the next step in using our EyePop plugin with our new Bubble app is to tie this into our workflow. So I needed to identify where in this app did I want to trigger that EyePop plugin logic. So if you remember, we would upload an image and then I'd click this button, which is upload and analyze. Down here, we can see that this will list out the name of the component we are hovering over. So on the upload and analyze button, it is called the button submit upload button. And this is where I want to trigger that EyePop workflow. So I want to send this image to EyePop. So if we go back into our editor and we go into workflow, we'll land in a page which looks like this. And we were on the button submit to upload button. So we just click that. So once this button is clicked, we just need to add a step. And that step, we click plus button, we go down to plugins, upload image. And that will lead to a page which looks like this. We want to pass in our image path, so that URL essentially describing where the image is, and send that to EyePop. Next, we want to show the results of EyePop's classification, as well as the material type. After we show that result, we want to hide the pop-up, and then we want to show the final card. And it's as easy as adding these 4 steps, and we essentially have now hooked up EyePop into our Bubble app. So once we go back into here, we can sort of debug this by clicking step by step, and we'll see in the backend what this flow is looking like. So we'll click upload and analyze, and we'll see this button is clicked. And then next, it's triggering the EyePop plugin. And then next, EyePop is returning really quickly that the value is trash, and then the material type is trash. Next, we're going to hide this pop-up, and we're going to show our results. But essentially, that is how I was able to build this app with no code, which has a custom computer vision model specialized on what I wanted the computer vision model to do. And I was able to get that running in less than 2 hours. Well, thank you guys so much for coming. I'm going to we'll record this video, and it's already been recorded, and we'll be posting it on our YouTube. And if you guys have any questions, please reach out. Would love to help out and answer any questions. And again, thank you guys so much for coming.